JUice is set to achieve something that no other spacecraft has done before. With groundbreaking scientific objectives and a timeline packed with fascinating missions, the JUice is poised to revolutionize our understanding of the outer solar system. Get ready to be captivated and watch this video to learn everything you need to know about how the JUice mission got started, its purpose, and the exciting milestones that await. First off, a short summary of how the mission came to be. The JUice mission is the European Space Agency's, ESA for short, JUpiter ICy Moons Explorer mission. It first started as a revamped version of the Jupiter Ganymede orbiter proposal, which was originally a part of the cancelled Europa Jupiter system mission called Laplace. But that didn't stop JUice from becoming a leading contender for the first L-class mission of the ESA Cosmic Vision program. And on May 2nd, 2012, JUice's selection was announced. But the competition was tough. JUice was up against some impressive contenders. Luckily, JUice was recommended over the others in April 2012, proving that it had what it takes to be a top-notch space exploration project. Imagine trying to build a spacecraft that can brave the harsh radiation environment of Jupiter while relying solely on solar power. Sounds like a tall order, right? Well, that was the beginning of the design challenges that faced the intrepid engineers behind this mission. But they conquered it all. Not only does the spacecraft need to withstand Jupiter's intense radiation, but it also needs to make some pretty tricky orbit insertions at both Jupiter and Ganymede. And let's not forget the countless flyby maneuvers that will be required along the way. To accomplish all of this, the spacecraft will need to carry a whopping 6,614 pounds, 3,000 kilograms of chemical propellant. There's also the matter of gravity assists. These include interplanetary transfers, Jupiter orbit insertion, and apocenter reduction with multiple Ganymede gravity assists. The highly anticipated JUice mission was set to launch on April 13, 2023, from the Guyana Space Center on an Ariane 5 launch vehicle. But unfortunately, Mother Nature had other plans, and the launch had to be postponed due to poor weather conditions. Thankfully, the launch took place on April 14, 2023, and JUice's solar arrays were deployed just a few minutes later. The JUice spacecraft launched from Earth with a mighty roar and soared into the endless expanse of the sky above Europe's spaceport in French Guyana. The ESA declared the launch a success, sending ripples of excitement through the scientific community. But that was just the beginning of this thrilling journey. JUice will undergo multiple gravity assists to propel it towards Jupiter, making flybys of the Earth-Moon system in August 2024, Venus in August 2025, a second Earth flyby in September 2026, and a third and final flyby of Earth in January 2029. JUice will even pass through the asteroid belt twice, making a proposed flyby of the asteroid 223 Rosa in October 2029. The JUice spacecraft is scheduled to arrive at Jupiter in July 2031. Once there, it will kick things off with a thrilling flyby of Ganymede to prepare for Jupiter orbital insertion just 7.5 hours later. Can you imagine the heart-pumping excitement as JUice embarks on its mission to explore one of the most intriguing planets in our solar system? The first orbit around Jupiter will be elongated, gradually lowering over time to eventually result in a circular orbit around the gas giant. In July 2032, the first Europa flight will take place. JUice will enter a high-inclination orbit to study Jupiter's polar regions and its magnetosphere. But JUice's exploration continues further. In December 2034, it will enter an elliptical orbit around Ganymede, with the first orbit at a distance of 3,106 miles, 5,000 kilometers. And by 2035, JUice will be in a circular orbit just 311 miles, 500 kilometers above the surface of Ganymede, diving deep into the study of Ganymede's composition and magnetosphere. It's a breathtaking mission that will provide invaluable insights into our solar system. But alas, all good things must come to an end. When JUice exhausts its remaining propellant, it will be deorbited and impact Ganymede at the end of 2035. The JUice orbiter is on a mission to explore 3 of Jupiter's fascinating moons: Ganymede, Europa, and Callisto. These icy worlds are thought to have internal liquid water oceans, making them key to understanding the possibility of life beyond Earth. JUice's investigations of Ganymede and Callisto will focus on characterizing their ocean layers, mapping their surfaces, studying their icy crusts, and investigating their internal dynamics and evolution. Plus, JUice will be the first spacecraft to study Ganymede's tenuous atmosphere and intrinsic magnetic field and how it interacts with Jupiter's magnetosphere. The orbiter will also be honing in on Europa's chemistry, including the search for organic molecules essential to life. And for the first time ever, JUICE will provide subsurface sounding of Europa, giving us crucial information on the thickness of its icy crust over the most recently active regions. But JUICE isn't stopping at the big three. It will be making observations of several minor irregular satellites and a volcanically active moon, all from a safe distance. Now, onto the scientific instruments on board. Bear with us. Some of these terms are a little technical. In 2013, a bunch of scientific tools created by different teams around the world were selected by the ESA to be used for the JUICE mission. These tools include cameras, spectrometers, radar systems, laser altimeters, and other instruments. One of the cameras, called Janus, is designed to take really detailed pictures of Jupiter's moons, Ganymede and Callisto, with resolutions ranging from 0.4 miles, 400 meters, per pixel to 2.4 meters per pixel. It has filters that can help identify different materials on the moon's surfaces. Another instrument, MAGIS, can capture detailed visible and infrared images of Jupiter's moons and minor gases, as well as study the composition of ices and minerals on the icy moon surfaces. The UV imaging spectrograph will study the exospheres and aurorae of the icy moons, detecting plumes on Europa and studying the upper atmosphere and aurorae of Jupiter. Submillimeter wave instrument, another tool, uses a high-tech spectrometer to study Jupiter's atmosphere and the surfaces of the icy moons. Gala is a laser altimeter that will study the topography of the icy moons and the tidal deformations of Ganymede. RIME is an ice-penetrating radar that will be used to study the subsurface structure of the Jovian moons. Other instruments on board the JUICE spacecraft include JMAG, PEP, RPWI, and 3GM, which will help study the magnetic field, plasma environment, radio emissions, and gravity field of Jupiter and its moons. The JUICE mission is a collaboration between the ESA, NASA, and several international partners, including the Japanese Space Agency and the Italian Space Agency. The mission involved a large team of scientists, engineers, and technicians who worked together to design, build, and also operate the spacecraft and its scientific instruments. NASA provided several scientific instruments for the mission, including a radar instrument, and was also involved in the mission's scientific planning and analysis. The JUICE mission team is also responsible for engaging with the public and sharing the mission's scientific discoveries with the wider community. The mission team conducts outreach activities, including public lectures, media interviews, and social media campaigns to raise awareness of the mission's objectives and the scientific discoveries it is making. To summarize, the JUICE will become the first spacecraft to orbit a moon other than Earth's moon. The spacecraft will conduct detailed investigations on Ganymede, Europa, and Callisto to complete a comparative picture of these Galilean moons, which are thought to harbor internal liquid water oceans and may support life. The JUICE mission represents a significant step forward in exploring our solar system and will provide valuable insights into the habitability of the icy planet. After 4 gravity assists and 8 long years of travel, JUICE will finally reach its destination, the gas giant planet Jupiter, in July 2031. We would like to thank you a whole lot for watching this video. Please feel free to like the video and subscribe to get notified when we upload more videos like this. Until next time.